So we learned that we all need to speak the same language, and hopefully we all agree that these are standard concepts in the OMOP terminology. Why do you think we also need to have a common data model? Correct. So we need to put these words into sentences, right? And the sentence in the relational database language is SQL. And when we would like to ask a question, we would like to have the same formalized approach to asking this question. So we need to structure our sentences in the same way. In order to do that, we need to use the same formal structure.
Little less close.
Okay. Is it better? Can you still hear me? Wonderful. All right. So that's why we need the common data model. So if we're talking about conditions or diagnoses, we know that a condition has a date, a provider that diagnosed it with, that it has other attributes, and they are uniform across, and they are uniform across. So when I'm running my query, okay, very good. Thank you. So when I ask a question about condition at Montefiore, and I create a query, I can send this query to our friends at Columbia, and it will hit the same structure, and hopefully the answers will be consistent with the questions that we are asking at different institutions. So that's why we need a common data model. So you are already familiar with this picture. It's the high-level model or high-level representation of the OMOP common data model. It has 5 major components. You are familiar already with the component that provides housing for the common terminology. This is okay. That's the standard vocabularies. The rest of the common data model major domains, they mostly contain patient data. There are standardized clinical data. There are derived tables that are based on the clinical data tables. There are also tables representing standardized health economics, and standardized health system data represents essentially lookup information for location care site and provider. There is also one lonely table here which represents the metadata description, the source where the data came from, and it's going to grow. And there are several foundational principles that are key to how the OMOP common data model was built, and they are helpful to drive your queries, to direct your ETL, and to extend the model to the next evolution. So the first principle is that OMOP model is it's an information model because it's a blend of conceptual model, which is a vocabulary, and data model. You will find concept IDs in every data table, patient data table that you're looking at. All the concepts are domain-oriented. So when we go back and look at the standardized clinical data, we see that they're broken into smaller domains. There is a visit occurrence, procedure occurrence, drug exposure. All these are domains. So each of the concepts that you saw in the terminology has a domain ID attached to it. This foundational principles will help you drive your ETL. So when you found a concept, a standard concept in the vocabulary with a domain observation, your ETL will know that this concept, this piece of patient data will have to end up in the observation table. The next principle, fundamental principle, is that the OMOP CDM is patient-centric. It means that you will find patient identification in every table that contains patient information. You don't have to join, as you would normally do in a relational data warehouse or a relational data structure, patient to visit, to condition, to find patient conditions, because patient condition, condition occurrence will always have a patient ID. OMOP common data model accommodates data coming from different sources. It could be EMR, it could be clinical trials, it could be claims data, it could be cancer registries. They come from different sources, which are very heterogeneous, and they end up in the same data structures in OMOP.
Question?
Sure.
When you're referring to patient ID, you're referring to an internal OMOP.
Internally generated patient identifier in the OMOP CDM.
But it doesn't have to be.
Well, I'm trying to make sure that we don't mean that the patient can be identified outside from the source. You can identify the patients within your database with your identifier.
Right. No, you don't have to preserve.
Social security number of
No.
patients are coming into your database, and that's what I'm trying to clarify.
In the process, if you need to re-identify your patients back in the source, there are mechanisms of mapping between the source and OMOP concept IDs. But normally, we are dealing with de-identify informations, and these are auto-generated, OMOP auto-generated concept IDs.
And then when you refresh the data from the same source, and I'm asking this question because we work with Sentinel, and
Yes.
sometimes the patient IDs from the source actually change. So my question is, when the same source is refreshing its data, the same patient will remain with the same ID?
If you are preserving the maps, then if the patient ID is changed in the source, you have to recreate a map to the target concept ID.
But one
Bec-
doesn't prescribe either way. If you want it, or you being the data holder, you can handle it that way, but it's not prescribed in the OMOP that the patient ID stays the same.
It will depend on the data holder.
If you,
Yeah.
yeah.
Can do each time do new ID if you want.
I think too, there's also a field where you can keep your ID from your source. It's called person source value. So if the patient ID changes with refreshing and your person's source value stays the same, you can still identify the same person run to run. But if your source changes the ID,
then you have to recreate the mapping. And again, because in the majority of use cases, we're using de-identify informations, those maps are preserved outside of and preserved and maintained outside of the model. We could talk about this at the break, because we had to go through this in the New York CDRN project, we had to preserve the maps, and we also had to maintain any changes in the source systems of the patient IDs. And we had help for that from local information exchange services. Sure. The other very important thing about and principle of the OMOP CDM, it preserves provenance or source data. It preserves it at different levels. You store, in addition to storing the standard concept IDs, you can store source value for all of your data. If it's a coded value like ICD-9 code, you also can preserve a source concept ID. If it's a custom code, like many lab systems only have text values, that's all you preserve. In addition to that, the provenance information that we preserve in the CDM, it's where the data come from, whether the source is the claims or the problem list or the billing information. And I will show you in a minute how it's represented structurally in each of the data tables. Very important. We have the structure. The structure is specialized, but it's not written in stone because we have one element or one table in the CDM that's extendable. And we call it a dump, we call it a playground, but this is actually a playground for the next evolution of the CDM. And it's very important to realize that on one hand, we have a strict structure, we have domains. On the other hand, we have this relatively free format table which allows to extend the model and accommodate new use cases. And the model is evolving. Even the tables that I'm going to go through, they don't necessarily represent the current state. And Clair is going to talk about the process, how the model is being developed. But these are the foundational principle of the OMOP CDM. So how these are reflected in the table structures. Patient-centric. As I said, every domain table has a patient identifier. For example, and it's called person ID, and person ID 123 will be propagated through the entirety of the clinical and other patient data tables. There is a unique domain identifier. So this is a unique key of each domain table. For example, for condition occurrence, which is a table containing patient diagnosis, there will be condition occurrence ID, a unique. Normally, it's an integer. It's auto-incremental key that represents the primary key of this domain or this table. For each domain, as I mentioned, there is a concept ID that will describe a diagnosis, procedure, drug, and it's represented by a standard concept ID. And normally, it's named by the name of the domain, condition, then underscore concept ID. And you might remember the SNOMED atrial fibrillation, which is the standard concept ID of this. Then there are several key fields that preserve the data provenance. This is the source concept ID. That works for the coded source concepts. For example, for ICD-9 or ICD-10 codes, if it's coded in the source system as ICD-9 will choose the condition source concept ID 4482197, which represents atrial fibrillation in ICD-9-CM. There is also source value. That's the exact way the piece of information is coded in the source system. So it could be 427.31. In a certain system, the dot will be missing. In other systems, there will be additional zeros. But that's exactly how it's recorded in the source system. For the coded vocabularies like ICD-9, ICD-10, or CPT-10, it may not be as important. For customized coding systems like lab text, it's the key to link your source value to the concept ID. This is also a very important piece of information to perform quality assurance of your ETL, to make sure that your source values are mapped to the concept IDs correctly. And the last piece of the provenance information is type concept ID, and that reflects the type of the source it's coming from. Again, for diagnosis, it would be either claims or problem lists or say cancer registry. And that will be reflected in this concept ID. And there is a vocabulary representing all these type of sources, and it's pretty granular one. Now we're going to go through tables, and we start from the first and most important table. We cannot do anything without it. It's the table containing our patients. It's called person. One patient must be represented by one unique record. We are not preserving history of demographics or history of locations for the same patient. That table contains demographics, gender, race, ethnicity. That table contains patient address, patient current address, and location. And there is a peculiarity about how OMOP CDM represents location. There is an individual record in the location table, which we'll review a little bit later. And in the person table, we are referring to that particular address ID. The only piece of information here that is required is year of birth. And we get questions, what if I don't have a year of birth? Probably you would need to do an approximation, because I don't think that you could do any research without having an age of a patient. Everything else is not required. We know that race and ethnicity information is, on top of being not clean, it's not necessarily available, but year of birth is one of the required fields in this table. Any questions?
Could you clarify what is the provider ID of the care site ID?
A provider ID would be a primary provider ID for this person.
And then the care site would be
And the care site ID would be the primary care site for that person. So again, we are not preserving the history. It's the current snapshot of, right. Mm-hmm.
If there was a specialty, then you wouldn't be seeing that.
Specialty, if your provider has a specialty and it's reflected in the provider table, but if you have multiple providers, you should pick up one for this particular table. The other providers will be reflected in the tables reflecting procedure performed, visits, diagnosis. So that will be a history of patients' interaction with your providers. This one only reflects the current primary provider.
So for the provider ID, care site ID, do you
the question is, which provider ID do you prefer as a primary provider? Which one do you choose? And it's a matter of preference, and I think it very much depends on the research question that you're trying to answer. For example, we were trying to, we were using OMOP database for recruiting patients for diabetic trials. So we did not necessarily, the primary care physician was our last choice. It was the physician that, there was an algorithm-based physician choice of the physician who saw the patient during the last 3 years most frequently. So it's, again, it depends on what you are trying to answer with the choice of your physician.
Is there a way, if you know the same patient has gone to different specialists in a time period, will that patient, is it possible for that patient in some place to be linked with multiple providers for different encounters? So
we're going to get to the encounters next. So this one, again, it's a snapshot. And the choice of the provider here would be the provider that has the most relevant relationship with the patient at the time you're running your research. But we will be able, and that's the next table. And so the location I mentioned quickly, this is a lookup of the locations. I will get back to this. I will get to the visit occurrence. So visit occurrence describes patient encounters with provider and facilities. And it has visits are not equal encounters. And there is an extension. I mentioned to you that the model is evolving, and we already have an extension to the model that reflects encounters, which are more granular representation of an individual visit. Here we have a high level 5 types of visits, which are outpatient visits, inpatient visits. We have a combination of we have emergency room individual type and inpatient emergency room visit. And this is done because not in all the source systems we can differentiate and break them unambiguously into 2, and we have a long-term care visit. Each visit is associated with, again, a primary provider. Again, there might be multiple providers associated with one visit, but we chose one. And then the other providers will be reflected in the procedures performed during this visit, diagnosis, diagnosed, and so on. This table was extended in version 5. We now have discharge destination and admission source, which are very key attributes of the inpatient visits. Also, what I would like to mention that all the other tables, except for the person, will have the temporal component. Some of them will have the start and end component. Some of them will have just the one date associated with an observation. And you will see 2 temporal attributes. One is visit start date, and this is visit start date time. And this reflects also an evolution of the CDM. Visit start date time have been added recently. And before, the time was represented as a string, and it was done for compatibility purposes with different relational engines. So now we assume that all of them support visit start date time, and hopefully in the next version, visit start date will retire. you may see remember the principles of keeping the provenance, visit source value, the way visit type was coded in the source system. Also visit source concept ID. Yes, and the same for admitting source and discharge destination. You have the source value. We have eloped as one of the locally coded discharge destinations. And if there is a coding system for that, that would be represented using admitting source concept ID and, well, right. Actually, here we don't have, because these local systems, they don't have a standard. So we only have the standard concept IDs, which is admitting source concept ID and discharge to concept ID. Yeah.
So if a patient was entering or getting a patient ID because he or she received a vaccine at a pharmacy, you wouldn't be seeing them under any of the visit types here?
No. And it's not required. And a patient may be just answering a survey, and there was no visit associated with that. So you will have a record of this survey, question and answer, in a certain table, and currently it would be an observation table, or you would have a record in the drugs exposure table without having an associated visit.
But just to clarify this, the themis working group actually is working now on the visits and what goes in the visit, and is a minute clinic or other things called the visit or not. So that we're going to have a convention which makes it, one way. There's no ambiguity. You don't have it yet?
Well, experience-based, I know that sometimes, well, you may derive it, but it's not easy, right? If you don't know, you don't know if the visit didn't happen. Yes. So back to a very important formal table, which is called observation period. This table is foundational to have the OMOP or OHDSI analytical methods running. And it reflects the period when the patient is observable. It could be derived very precisely based on the claims data. Or if you're working with the electronic medical records, you don't necessarily know all these discrete time periods when the patient was observable. So you derive this based on the first available encounter and ending with the last available encounter date. But this is, again, foundational. This is required for the OHDSI methods to run. So you must have this in the database. Death table indicates, one death record per patient, regardless of what you have in your source data. And as you know, you may have multiple death records coming from different sources with a different degree of confidence. It's the choice of ETL, and it's the decision, the ETL decision, which one you choose. And it has a death cause, but it's not necessarily available all the time. Okay. Procedure occurrence. So this is everything that, all the procedures that have been performed for certain patients. This is probably the worst terminological domain because it's based on a mix of Hripcsak, CPT4s, nomads, and that's the reality we're dealing with. If there are questions, I will defer them to Christian, but as far as I understand, there are no good mappings between these vocabularies, and that's why we are accommodating all these coding systems. So procedure, again, the principles, the primary key for this domain, the person ID key present. We don't have to connect to the visit to understand what procedures have been performed to a patient, procedure date, time. We don't have procedure start and end date, which we'll probably have to fix in the next versions. This is the provenance where the procedure comes from, which type of the sources. There is a procedure modifier. For example, if you're performing a surgery, the modifier will indicate whether the surgery was done on the right or on the left side. And there could be other modifiers that are recorded as standard concepts. Quantity of procedures, there could be more than one. Which provider? If there is an associated visit, it will be here, but it's not required. And again, the provenance with the procedure source value, procedure source concept ID, and modifier source value as well.
Just a quick question. So if the drug is, so if I'm working on a drug that's given through infusion, and I know Christian mentioned that even if it's infusion and it has Hripcsak or CPT4, we still look at the ingredient. So in that case, I don't have to also look at the procedure codes, right? I just have to look at the ingredient. That's good enough.
You may have both records. You may have a record for a procedure, which is what was in infusion, and you may have a record for what exactly was infused, which is a drug. There are some concepts that we call dirty concepts, and I will talk about them later, where they are coded in the system that's intended for coding diagnosis, but essentially it's a procedure. But the linkage between the source code and the standard concept ID will prescribe which domain this record has to go to. And there are mixed domains too. So you will find a small subset of concepts in the terminology that have these mixed domains.
So what you're saying is if I just relied on the ingredient, then I might be missing
No.
some.
In the drug, it's going to be in the drug table. It may be in the procedure table. The reason whether it may or may not be in the procedure table, is it goes into Themis right now too, is because the docs actually, if they put a Hripcsak in, they have to put a CPT4 in saying, I put it in. Okay. But there may be situations where that's not the case. So the procedure of putting a syringe into the arm is usually not something which is captured, but if it is captured, then it is captured.
On the other hand, chemotherapy.
Chemotherapy,
There may be chemotherapy administration without even a reflection of what has been administered, and it would be in two different tables in the source, right?
definitely in the drug.
Right.
What's your normal technique for keeping some of the injection?
That is subtle. It's called subtle. Depends on the patient.
And immunization is a very good example of that. It might be just a procedure without an indication of the drug, and it will end up in the procedure tables. Yes?
It seems like all tables, whenever there's a concept ID, there's a concept source value, except for the types. I don't know if there was a conscious decision not to have the type source value.
No, it's a conscious decision because types indicate the type of sources. Again, whether it's claims data, whether it's billing, diagnosis, whether it's EMR. So these are, by the way, OMOP-generated concepts. So I'm ruining the legend that OMOP doesn't generate their own concepts. There is a need sometimes in all the types of the sources. Again, could be claims, could be cancer registry, and they're pretty granular. They require a better organization than it is now. They require a better hierarchy, but these are OMOP-generated concepts, and they only describe the type of the source. They are not really recorded in, this, in the source. Okay. Condition occurrence. These is a table where we record patient diagnosis. You've heard that our common language for talking about diagnosis is SNOMED, and hopefully you will be able to map all of your source codes to SNOMED now without any difficulties. The data sources are different. Again, the concept type IDs could be the billing diagnosis, could be problem lists, again, cancer registry, and so forth. The history of diagnosis is not recorded in the condition occurrence. And observations, symptoms, are not recorded in the condition occurrence. This is a designated place for conditions. Mui is going to talk to you about further processing of conditions which indicate the disease episodes, and that's the condition era. And that's the further use of the condition occurrence table. I mentioned dirty conditions. Here we have the CIM-10, I was told is a German coding, diagnosis coding system. And we here have an example of 3 different flavors of things coded in this presumably diagnosis coding system. One is drug, another one is an observation, and the other one is condition. So the mapping between the source system and SNOMED will, again, prescribe which of the tables, which of the domains this particular record or observation will have to go to. Drug exposure. You've learned a lot about drugs, so this is a table which reflects what drugs the patient has been using, and it has all the wonderful attributes which may or may not be available. The primary one is the person ID and drug concept ID, which will reflect an RX norm drug. Then the start and end date, the stop reason, the number of refills, the quantity of drugs, the days of supply. I don't remember what the SIG is. The route of drug, the orally or topical drugs, the lot number, and this is also a specific indicator on the prescription. Provider who prescribed the drugs, whether it was the drug prescription was associated with a certain visit. Occurrence ID, not necessarily, again, not required. And then the source value containing the drug provenance information. Okay. Yes?
So in a claim, there are multiple diagnoses 1, 2, 3 on a particular business
there will be 5 different types of diagnosis. I don't believe we have version 5.2 here. We have added this stage at which diagnosis was assigned. There are admitting diagnosis, there are intermediate diagnosis, and there are final diagnoses that are normally associated with the final billing diagnosis. But if there are multiple diagnoses, yes, they will all go here. The primary, sorry.
The concept type ID, the concept, condition type concept ID is what you would fill in if you want to say it's your
Primary or secondary, right.
Or your secondary or your third. Now, if for most claims, they fill in the same concept, the same diagnosis multiple times, right? That's how claim forms are filled out. You don't repeat those. Those are not duplicates. So you would remove those duplicates and you would take the most priority position, or in my case, the lowest number, because it's diagnosis 1, 2, 3, 4, 5, right? So, but it's that type concept ID up there. That's what we're talking about.
Yeah, but you may have duplicates if your diagnosis is coming from different sources, if they come from EMR and claims. Again, there is a source condition type concept ID that currently indicates primary versus secondary. Admitting, final, and preliminary is indicated by a different field which is not listed here. In version 5.2, yes.
And the visit occurrence ID is the same for all 5 records?
Say it again, please.
The visit occurrence ID is
Yes.
the same?
Yes, the visit occurrent, if this is the same visit, yes, definitely. Right, right, yes. Any other questions?
Clarify, I think that was the next slide. What does lot number, what kind of information does lot number have?
I will defer this to Christian or Mui.
Under drug lots?
Right.
Lot
The lot number, yeah, I don't remember.
The
Mhm.
the drug itself, the vaccine, what would that drug?
I think it's a lot number the way you think about it. I didn't even know we had it.
Yeah, it is.
Well,
It is. It's a lot number you
I don't think anybody has anything. We
It
can
is the
ask
way
the
you would
question.
think about it. We don't
Yeah.
have,
Nobody has
most
that.
places don't have lot numbers. Right? And the SIG is your instructions, right? Like your once a day, twice a day, 3 times a day. So your prescription, the instruction, that's what the SIG is if you have it. But if you don't, no. The lot number is like what you said. It's like you have multiple, right? The lot number is not on your box. It's lot number on it. So that's what that is.
If a record has that information, then
you put it in if the record doesn't have this information. You
Yeah,
don't,
just
right?
because the tables are there or the fields are there doesn't mean we filled it, right? Or we don't put zeros in there. If you don't have it, we're not making up anything.
By the way, about not putting zeros, I don't believe that we mentioned the concept ID 0. Did
Yes.
we? So we have this fantastic concept ID which is equal 0, which means we don't know how to map the source code. So rather than using, there are actually 2 workarounds, but one and the most appropriate one is to use concept ID 0. You will still have your source concept ID and source concept value, but there is no standard concept to map to. Yeah.
So drug exposure. Rimma went through this and kind of explained to you guys what many of the fields are in drug exposure. One of the things we do want to show you is what Christian and Rimma has been saying. When you do the mapping in the ETL, you want to make sure you're following the domain of the actual concept itself. Because not everything that in the source data, just because it's in your drug table, is an actual drug, right? So to give you some examples, this first one, I don't even know what it is. It just says observation period. That's not a drug. That we put into the observation because it's some kind of documentation. So, you know, it's a piece of paper somebody wrote down, but it was in our drug table, so we move it out, okay? The next 4 are examples of things that are really devices, but because maybe in this data set they were considered drugs because there was no such thing as a device, right? So this is a belt, a lumbar belt that you put on if you have back problems. This is a mask, right? People wear a mask, and the next one are needles. So those are all in the OMOP vocabulary considered devices. Now, go ahead.
Are they different than medical devices or implantable devices? Is a device that's just not a medicine?
Yes. So it can be like you said, medical devices or just other type of
I
devices.
think they're referred to as durable medical devices.
Okay.
So, can I ask, are these the ones that are regulated by the FDA devices, the Center for Devices?
Rimma in the back is nodding her head, so that's a yes.
Okay, thank you.
Christian isn't in here. Normally I say Christian, except, or Dima.
Yeah, what was it?
See, this is how you get them to pay attention, not you guys, but them to pay attention to the class, right? So one of the questions we get a lot when it comes to our analysts looking at this is they may or may not agree with where the OMOP vocabulary decides to put something. And what we end up telling them is, that's great. I really love the fact that you're actually looking at what we did. But I'm not a medical person, so you can't have that discussion with me. I would love to introduce you to the forums and have you go put it in there and post under our vocabulary section and put that opinion or fact, whichever way you want to look at it, out there. And someone like Dima, Rimma, or Christian will have that wonderful discussion with you. And they're really fast at posting too. Okay? They probably post within seconds. You'd be surprised.
But we will go through this a little bit later. OMOP is the only database that has FDA-regulated device IDs. So we are mapping to FDA-regulated devices.
So what Rimma just said is we are mapping the FDA-regulated devices. Okay? Great little segue into devices. Devices. So just right there accommodates FDA unique devices, even though most data sources don't have them, right? Rimma, don't skip ahead. But very similar to the other tables, you'll see the device exposure ID, then the person, the dates, the unique device ID, the quantity, the provider who prescribed the device, and the visit occurrence if you got it via visit. Doesn't have to be, could have been mailed to you, right? Then you wouldn't have a visit. And then the source value and the source concept IDs. So again, all your device information would be stored in here. Okay? Measurements. 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 Measurements is where most analysts loves this table, because if they can get all their measurements unified and everything, it would be the best thing ever, right? Because, oh my God, you can now look at everyone's weight and height and not have to convert them to pounds and kilograms and inches and feet, right? ETL's worst nightmare. Because most of the time when you get measurements, again, measurement stores your lab values, your lab results, as well as your body mass index or other stuff related to that. If you ever look at most of the EMR systems or any systems that carry your measurement information, typically that data is extremely dirty. And it's not anything wrong with this model. Okay, this model is awesome and great, but the data that you get is wonderfully dirty. Either it contains a bunch of text fields that somebody has to manually read through or write some kind of algorithm to get to, and then you have different unit of measures in there that you have to then either convert or say, I'm not doing it or I quit, right? So again, measurements to a lot of the analysts, the data scientists, it is an awesome table. It is great, because if you can get it, you get a lot of value out of it. Yes?
So measurement, any numerical information will go to measurement.
It's not just numerical. It's also any type of results, right? So like yesterday, someone asked me, we were looking at urine sample or urine results. It's not just numerical. It's not positive or negative. It was the color. What are your different color? And your results would be the different color of the urine samples. Or your quality of life index, it could be.
But
right?
you convert the color into categorical variable, is that right? Like 1, 2, 3, but not exactly put the text information into
No, the text can go into what we call a value as a concept ID. So in the example of the colors, right, those can be concept IDs. Blue, well, you don't have blue urine, but you know, we have green, red, white, yellow, right? So they can be converted into actual text values, but we call it concept value as concept IDs. If they're numeric, then they would be the value under a number, right? So your weight, your height would be numbers, and then your unit concept ID would be your unit of measure.
So your value as concept ID actually not concept ID is if I have categorical string, if the measurement result is string, then I put it here, right? It's not exactly as concept ID.
No, it's the concept ID. It's the ID that ties to the concept name of the string. So your concept name in your concept table would be yellow, but the concept ID is 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 would be stored here. And then you would just have to again go back and look.
Sorry, I have to ask you again. So I have data for the hearing, you know, the hearing. Test.
Data for hearing.
The data is really dirty. So in the one column, it contains, as what you said, numeric information and also types and string are very mixed information. So when I try to think about where to put information, measurement seems not the best choice because we have the data has string or different information. Is that okay if I split the test results into measurement and observation? Observation is kind of a category like string, right? It's kind of
No, so this is why I say ETL people hate this table, because my whole team does. They hate it. You have to actually, in your ETL, clean it up. You have to spend the time cleaning up this table. You don't put half of your measurements in measurement and the other half of it in observation because, again, the reason for an OMOP CDM model is that so that anybody who doesn't even know your data can go and run a query against it, right? So if I made a special rule to say, oh, half of my measurements is here and the other half is in observation, then someone has to know your data. And that goes against the definition of what a measurement is and what an observation is. So in your case, what you have to do and work with your different business folks to do this is to actually clean up that data. Now, I'm not going to go through the methodologies in which you can use to clean up the data because I can go on for a whole day about them, honestly. If you want to, we can talk about it afterwards, but the gist is you have to clean it up. You should clean it up.
If I may add, you will preserve your source value like red or blue or yellow in the source concept value. But in order to record an analyzable measurement, you will have to convert it to a concept. And for qualifiers, for values concept ID, we're mostly using SNOMED. For measurements, for the measurements themselves, like lab names or vital, we're using Loin codes. But it's either numeric or concept ID. Strings are not allowed in here because these are analyzable measurements.
Okay. Okay, so again, you helped me go into my next slide. Why do we not like measurements as much? Right? This is just an example to show you the inconsistency of the data. This is one data set that we had just for the same cholesterol test. You'll see these are the unit of measures. Right? I don't know what this greater than 3-2 means. This was a European data set, so it was 3.2. But this is something that your ETL team really has to go through and clean up and to get consistent. This is an example for you of the values in here. Even though we do have LDL, right, a ton of them were zeros. So it kind of helps you, gauge. So these are some of the methods you can use to gauge. Do I really want to spend the time looking at these guys? Or do I focus my time on the ones that really, truly mean something to me? So, okay. Observation. the one table that you can pretty much store anything in. One of the things that we talk about the OMOP CDM, it is very extendable. And one of the ways to extend it is to use the observation table. Now, don't go put don't put drugs in observations when you're supposed to go into drugs. But if you have other things like smoking status, or if you have surveys, right? Someone answered a question, yes or no, you can put it in here. Here, like Rimma said, there is a value as a string because we don't believe that we can map everything, because not everything that you can think of is mappable out there. So we do allow you to store things in here as value as a string.
So
Yes?
for provider ID under observation or under measurement, do you use the provider ID of the lab that performs the test, or is it the hospital or the private care or the specialty physician who orders the test?
So when we do the ETL, we normally use the person who did the test, because that's the person who actually physically did the test, right? It's not unless you were trying to capture the person who ordered the lab, right? But the ordering of the lab is not the same as the results, because the ordering of the lab is the procedure, right? The measurement is the result. So that's the actual person the lab technician who did it. So you're welcome. Any questions on observation? Yes.
Do you normally then have value as number, value as string, or value as concept ID, or I guess my assumption was value as concept ID was the concept ID for either of those two. But it sounds like I'm wrong.
Sorry, repeat that question again.
On a normal record, you have a value. Would one of those three columns be filled? Only one of those values?
Yes, only one of those would be filled, because it's either you found it as a value as a concept, or it's a value as a number, or you don't know what it is, so you stuck it in value as a string.
And then so for the value as concept ID, where would the source be for that?
The source is under the observation source value.
So
for all three of them, actually, the source would be the observation source value.
So if we had like married at diagnostics, I guess, it seems like those are going to be values of an observation. I'm not sure how to ask this, but I guess the observation source value, I guess I was assuming was like the overall category of observations.
No, so like for example, if you have smoking, right? Smoking is it would be, your observation concept ID would be smoking, whatever the concept ID for smoking is. And then your value is did they smoke once a day, twice a day, 3 times a day, or are they a smoker, or are they not a smoker, so a yes or no value, right? Yes or no value would go in the concept as an ID, because we actually have a concept for yes and no. We actually do have concept IDs for, smoke once a day, twice a day, 3 times a day. Or they write, I don't smoke, or they write something else in there as a text value instead that doesn't match any of those, then that would go into value as a string. And then whatever your answer is also is stored down here as the source value.
So we don't capture the smoking as a category.
No, you capture it as the observation concept ID. Okay?
Thanks.
The qualifier concept ID, Christian.
Yeah, I don't know why you trying to put the fingers in the wound all the time.
I know, they like to do that. Can't help it. It's
See this thing. In the US system, you can have qualifiers for the claim. So you have a procedure and it's like on the left, on the right. Or it is, you can say, I did it as the main or as the assistant operating. Things like this. These are qualifiers. Right now, we don't treat it as, so Themis is going to fix it. So give us a couple months and then we're going to fix it. Right now, they are independent. I'm going to bite into it. They're going to be independent. They're independent concepts, which kind of live parallel to each other. So the modifiers aren't really used as modifiers. Most of them we don't care. Whether the provider was an assistant operator or not. Not that many use cases. For the hospitals, who have to pay them money and so on, that's very important for us. But yeah, we need to fix it.
yes.
More
Go ahead.
more for measurements maybe, but on the units, during ETL, are you supposed to be converting to a standard unit?
That's go ahead. So he asked, for measurements in the units, do we convert everything to one unit of measure? That's a great question. Come join our Themis meeting and we can resolve that for you. And you can help us come up with the resolution because I asked this exact same question 2 days ago.
But right now we don't.
Right now we do not.
However, so all the percents, so if the source value, if the source says percent and PCT and the percent sign and P and PT, okay, all that goes harmonized into one concept ID, which stands for percent. But what we're not doing is to say, well, percent really is the same as milligram per deciliter, and you can convert that to millimole per liter for this particular analyte. That's what we're not going to do. But you're not going to get the yucky original units that come from the clinical labs because they're just chicken scratch, whatever they feel like they put in there. And so that gets harmonized, but not we are not converting one unit into another unit. We find all the different ways to represent one unit, and that's going to be harmonized, but not conversion from one to the other.
You have to do that conversion on the fly.
So first of all, of course, people should get off the stupid inches, and all should use the metric system. Okay, then we solve that problem. But yes, so right now it's still on the analyst. It's not that bad. So height you have inches and centimeters. Weight you have kilos and pounds, and I love it in the UK, stones. Okay, I'm 7 stones. Yeah. Is that okay? Is that the argument? The counter argument? So yeah. So it's not that many. So if you really have to harmonize an international multi-center study that way, it's not that bad, right? It's much better than it is now when you get the raw, because there you have literally 25 different ways to say percent. Okay.
Okay, for time constraints, we're actually going to move past a few of these. Actually, we're going to move past all of these. Well, yeah, we're going to move past all of these. We're going to move past facts relationship too. Sorry. We're going to spend a little bit of time on drug error. Okay, so you guys learned earlier about drug exposure. And one of the things that Rimma said, yes?
Sorry, just about drug exposure, there was a start date and an end date?
Drug exposure has a start date and an end date, yes.
What's the end date?
The end date is when your exposure ends, and it's calculated based on what the information you know. So in the United States, you typically have a day's supply. Right, so you would calculate the start date because you know when they picked it up, and our assumption is the day they picked it up, the day is the day they took the medication, right? Started the medication, and then if it's a 30-day supply, you add 30 days to it. If you didn't have that formula, like in a lot of the European data assets, you would figure out what the duration is and then calculate, and then put the end date in there. Okay, so the drug exposure is at the transactional level. It's every single drug you took, right? Drug error is one of the derived tables that Rimma talked about earlier that we calculate for you. Now there's already an algorithm to calculate the drug error out there on GitHub. You can choose to use it or you can choose not to use it. Drug error is something that is populated while you do the ETL. But sometimes analysts don't want to use it because we use a very standard methodology, which I will go over with you in a second. But one thing that's very important about the drug error is we go at the ingredient level. We do not go down to the product, the form, the strength level. An error is how long a person was on that ingredient. Okay, and for that ingredient, you can have multiple errors because they could have stopped it and then went back on. Okay, so how do we calculate drug error? And why did we end up picking this methodology over any other methodology? Right, so we look at a patient and they started taking this particular drug and it was a 30-day supply. And then they got another refill for another 30 days. And then this patient, or in your claims data, for some reason, it ended up getting reversed out, right? So you got a reversal and then you got a brand new one. So, you know, one of the things that for calculating of drug error is how do you deal with reversals? That's one of the things that people will put in there. Yes?
So I don't know what a reverse app is.
A reversal?
Is that a US thing?
Oh yeah, it's a US thing, so it's in a claims, it's when the patient actually didn't pick up the claim or pick up the drug, so it got reversed out of your claim system. So one of the things is how do you handle reversals? Well, how about if the patient then continued and then took another drug that had a similar ingredient, but just something different, right, for 60 days. And so how do we change, how do we handle the change of an NDC number to a totally different brand name? Because they changed brand names, let's just say, right? Because that's something you try to put into the drug error. And then what if the patient then decided, you know, to pick up a prescription early? Because we never pick up our prescriptions early from a pharmacy, right? So how do you do that? How do you handle the overlap? Do you actually extend the duration, or do you just say the patient stop, you know, you drop the rest and just start from right there, right? Do you do an overlap, or do you continue and add on? So those are some decisions you have to make when you're doing a drug error, right? Another one would be then they went back, but then now they changed the dosage, right, from 5 to 10 milligram. Now, how do you handle a change in dosage? Those are a lot of the questions that you ask when you calculate drug error. Now, then they decided to take another one, but there was a bigger gap of more than 30 days. So what is your calculation for handling gap? How do you handle gap in error? Right? Lastly, they took, again, a combination drug. How do you deal with combination drugs? So again, all these are different scenarios that you typically think through and ask about when you're doing drug error. Well, OMOP simplified it. We said, okay, all of this, you look at most of your standard analysis, we don't always go down. Very rarely do we go down to the product form strength level. We typically go to the ingredient level. If you look at the cohorts, you're always asked, give me those people who are on diabetes that took metformin. They don't really look at, oh, give me the ones that only took the 500 milligram, give me the ones that only took 200 milligram, right? It's at that level. And what we do is we just ignore, we don't deal with these overlaps. We just say it's an overlap, okay? And our gap here is always 30 days. Now, what we typically get is saying, that doesn't work for all medication. We're not saying it works for all medication because some medications, the gap needs to be a little shorter. Antibiotics, 30-day gap doesn't work. There should be no gap because you're constantly taking antibiotics, right? But again, the OMOP is something that's standardized and it doesn't handle every single scenario, but handles a majority of scenarios. So for the scenarios that it doesn't handle in the gap or in you want this to actually start over here, like contraceptive pills, right? You don't want this overlap. You want it to start over here again. Those, you can go into the drug exposure and calculate your own error. But for the majority of the other ones, you already have it calculated at 30. Okay? So in our case, we create two errors. One is this first one, because that's where the stop is. This is the second one, where we then create the error, and it keeps going on. Okay? Cool? So just to give you guys some real-life examples, because I've had this question earlier asking, how does this all work? Right? I can't picture in my head. You guys are teaching me the vocabulary. You're teaching me these tables. Give me some real-life examples. Give me some visualization that'll help me. So these are 4 different systems. 3 of them in the United States, 2 of them in Germany, thus German DA. The first one is a claim-based system. you'll see this is the admitting diagnosis, and this is diagnosis 1. It's a ICD-9 code without a dot. This is an open claim system. This is also ICD-9 without a dot. This is a German EMR system. It's ICD-10 with a dot. Okay? This is a US ambulatory system, ICD-10 without the dot. So very different systems. If you were to run these analysis on your own, you have to fight 4 different types of code against it because they're all in different places, different fields, right? What we do in OMOP is we standardize them. So we take each one of these, one at a time, data source one at a time, and the first thing, just like you guys were doing in the morning exercises, you're gonna go figure out, right, what's the source value? Put this into the source value. So this guy is a source value. So earlier someone asked about, the positions, right? So we have the inpatient primary position, the inpatient first position. So we're gonna keep those. We do not dedupe these because one is the admitting diagnosis and the other one is the primary diagnosis. But everything else after we dedupe. And then we're going to say, okay, this is the source value, but what we also want to store is the source concept ID. So I have both of these. I'm retaining this, but what is my maps to? What did I map to? What's my standard that I map to? So this is the standard that it maps to. Okay? And then you take that and you do the same for all 4 of them. So all 4 of them, this is our source value, right, straight down here. And what we then do is we say, what are their maps to? So why do we actually, one of the things we get asked a lot is, why do we need to store this condition source concept ID? Why not just the source value? Come on, I know those IDs. I'm really good at my ICD-9, my ICD-10s, right? But again, what you'll notice is this has a dot, this doesn't. So you have to know in your own, these different systems, one has a dot and one doesn't have a dot. So that's why we introduce this ID, because now you'll notice all 4 of these have the same condition concept ID, right? But these 2 down here have the same condition source concept ID. So without having to know that this guy has a dot and this guy doesn't have a dot, I can query all of these. I can query across all 4 of these easily within like seconds. All I have to do is change the database connection and kaboom, I got it. Okay? So we kind of walked through a lot of the different tables, and one of the things we talked about in this class is about CDM and vocabulary, and it sounds really cool and really great, again, for analysts because you get to use this common data model, you get everything all standardized. But there are people who have to spend the time to put them into the standard model. One of the things sometimes people get confused is they think the model itself already has the data in it. Yeah, that doesn't work that way. Somebody actually has to take all your source and transform it into the actual CDM model. Put the data into the actual CDM model. Well, these are some of the challenges, or what we call lessons learned, we want to share with you. Not to try to scare you off or anything, but just to show you that if you put the work up front and invest the time up front, then you get a lot more in the end. But that time up front does take some time, and it does take a lot of iterations before you can get it perfect. So don't think that your first shot through, you're going to get everything, because that's a false impression. I know that. 2 years of this, I know that. So here's some of the stuff like date shifting. We actually do have logic in some of our databases because we cannot show the exact transaction of a patient. Regardless of who the patient is, when they went in for what, doesn't matter. We have to shift the dates. So we have logic in there to actually shift every patient by plus or minus 7 randomly. Because one of the things we have to keep is that integrity of their duration, right? That they went from the first diagnosis to the second diagnosis. We have to keep that duration the same. But I can't tell you when they went to the doctor. So I have to shift that whole patient's record by the same amount. But I randomized that logic because if you knew patient A was shifted by the same amount as patient B, then you're going to be able to figure out some kind of algorithm. So we do actually run into things like that. Encrypted or de-identified payer and provider plan information. So some payer plan They have vendor agreements that you can't disclose any type of information about that payer or about that plan, because that can potentially identify that patient somehow. So we have to encrypt it or somehow de-identify it. So even though you remember in your provider ID table, maybe your provider is numeric and you think you can store it in there, you may not because of some privacy rules, right? So there's a lot of different privacy rules that kicks in. Privacy, next one is privacy. ICD-9, ICD-10 codes, there are codes in there where this is actually a debate we had in the Themis working group 2 days ago. How do we note these? Because privacy is very big in the United States as well as all over the world. You don't want to be able to identify that patient in any way, shape, or form because you are working on de-identified data. Now, for those that are in PHI, this isn't a problem, which stands for personal health information, which means you can see all of their personal information and private information. But for those that are outside of that, it is very important that we do this. So certain things like sexual abuse, or you died in a very horrific car accident, there is a potential chance that if you lived in North Dakota somewhere in some mountain and you got in a really horrific car accident, it shows up in the newspaper, and you know their age, you know approximately where they live, and you kind of know the date of death, you can potentially identify the person. So there are rules where if it's those type of privacy codes, we don't show them. So that record at this point in time is removed from the database or removed when you do the conversion. So again, we talk about data loss. Data loss is not, it happens. And it's not always it's not a bad thing. It's about cleaning it and about the quality of data that you do. Because ultimately, your analyst has to put the exact same rules when you do the analysis. So why have 10 people repeat that rule that they could code incorrectly? Instead, put it in your ETL and it only happens once, right? Certain data aren't allowed to leave the country, so that's why we have remote studies. So it's ability, that's why we want everybody on the common data model, because then you can go and write the query and send it to somebody else, and it never leaves their hand, never leaves their country, right? Because we have many of those. France is one. Next year, they're going to put in a rule that you can't really disclose, you can't really sell any patient-related data at all. So how do you handle that? How do you, non-French get into that data? Well, you move it into OMOP, then you can do remote studies on top of that. Pilot patients, believe it or not, we have them in there. Why? I don't know. They're dummy patients. People want to put in there for test. You have to get rid of them, right? Patients without transactions, those are valid. Some people are that healthy. Some people never go to the doctor, right? So you shouldn't be dropping, and a lot of people think, oh, I should drop them, right? Because there's no transaction. What do I need them for? Well, they're in the denominator of the studies that you do. So you have to really look at every data you have and really truly understand whether or not they are being used for analysis or not, and whether or not you truly want them in the OMOP CDM, okay? Local country vocabulary mapping. Dima and Christian loves this one because in the United States it's pretty clean. We have NDC numbers, although NDC numbers aren't perfect. We have Hripcsak, we have CPT codes, right? We have ICD-9, ICD-10s. Well, in many of the other countries, they're not that clean. They all have their local version of ICD-10 WHO. They all have their local version of ATCs. They're called ephemera ATCs, or old ATCs too, and ephemera ATCs. And on top of it, they're local. So there's a lot of mapping if you're working with international data assets that you have to get through and get past and properly map before you can actually put them into the OMOP CDM and actually do this whole just taking a query and running it, okay? Local knowledge of every country's health system or your database, because most people, if you are ETL, you're probably just a developer. You're not a medical expert. So there are going to be rules that you don't know. I didn't know there were privacy ICD-9 codes that I needed to remove. Honestly, I didn't think about such a thing. You actually have to have the local experts to help you do that ETL and talk to you and pull all that analysis and all those use cases from them in order to do a a quality ETL conversion and to move that data into a quality OMOP CDM. Okay. We kind of talked about this ability, cleaning up dirty data, right? Measurements is a great example that you have to go through a lot of cleaning. Well, it's the next one. And then source fields not transferring to OMOP CDM. Love that one. Everybody always says, I need that field. But why? Why do you need that field? Well, I needed to calculate this. Well, we already calculated it for you. But I need it every now and then for this. Oh, every now and then. So you really don't need it, right? Again, the OMOP CDM isn't there to store every scenario that you can think about. There is nothing wrong every now and then to say, go back to the source and do the analysis. There is nothing wrong with that because, again, OMOP CDM does not cover everything. We are trying to extend it to cover a lot more use cases, but it still does not cover every little use case, every unique use case that you want to get to. It is there to do the majority of your outcome evidence, and they're based on a community of what they are interested in. Right? So if you have use cases that you think that you want to target, put it on the forum. Join the OMOP CDM and vocabulary working group and tell them. Write a proposal to change it. I mean, Gowtham, who's not here anymore, he's from the payer provider space, and he's like, the CDM model doesn't cover enough about claims. From a payer provider's perspective, I would like to add more. So he went through the effort, wrote up the use cases, and wrote up a proposal. And they're now looking at it. So it's a very open community, but I do want to say it doesn't cover every use case. Now, what we would love to do, because everybody has their own rules, right? Everybody in this room probably has their own data asset. Some of you guys have the same data asset, but you have your own rules. When you do conversions, you all have your own rules. There's a wiki site for OMOP CDM to cover it, to conversion and everything, but everybody interprets the same word a little differently sometimes. So what we are forming is a group called Themis. We met for the first time 2 days ago, and what we want to do in there is to come up with a standard convention for converting data. So what are all some of the standard guidelines you want to follow? Now, they're not, of course, all going to be the same because, again, EMR and EHR is very different than claims. And it's very different than registry, very different from survey. But if we want to put in guidelines there to say, if you have EHR, this is what you should do. If you have claims, this is what you should do. If you have this is what you should do. Now, for this field, it's standard for everybody. Right? So those are some of the rules and some of the things that the Themis working group is trying to cover. So all the stuff that I went through earlier, this is only 2 pages. It's actually like 10, 20 pages long that we went through 2 days ago. So there's a lot already that people have learned and is contributing. And we want to share that knowledge by putting in some kind of standard and guideline so that people don't have to go through the same hurdles that people like me and Erica have gone through in the last however many years we've done this. Okay? So if you want to join this working group, feel free. It's out there. Any working group, we love having new people join. Okay? So again, what makes the OMOP CDM unique? It's a specialized CDM that reflects on clinical domain. It's granular, it's well-structured, and it's extendable. Okay? Its vocabulary is actually one of the most powerful things in the OMOP CDM because once you actually get all these different countries' vocabulary in there, right? It's like an English translation. Now, English may not be the language of choice here, but I'm just using that, right? I don't have to go learn French, German, Australian, all these different languages, and I can all understand the same thing. Sorry, I do know Chinese, but even there I'm limited. So, so you don't have to know that. And you actually don't have to be a medical expert on it, because if you remember what Christian went through in the vocabulary, it's all spelled out for you in those ancestor and those relationship tables. Programmers, you guys don't have to dig up all the NDC numbers anymore, right? Just go do a descendant. Go find the descendants, a kaboom of an ingredient, and there you goes all your NDC numbers. Instead, today you go to a clinical expert and go, what are all those NDC numbers I need? And then if the new NDC number comes in, you have to add it. You don't have to do that anymore. It's none of that. right? So again, it's specialized yet extendable. So one is extendable via the observation table. 2, come to the OMOP CDM working group and help us extend it. Provide us with the use cases, provide us with the knowledge sharing, and extend it. It's extremely community supportive. These 2 over here, they will respond to you within seconds. That's probably what they're doing right now, is checking the forum and responding. I think during the hackathon, we had a quote in there that someone said about Christian, that he needs to stop responding so quickly and let others speak. That's how fast he responds.
No, that's not somebody said it. The forum. The software.
Oh, the software told Christian to be quiet. Okay.
This subject seems to be very important to you. Maybe you can consider to let other people. The forum said it.
So, yeah.
That's embarrassing.
But I love that. You know, I love using that. Sorry, I like messing around with him because he's easily mess aroundable. Again, it's development driven by analytic use cases. It is not driven by one person. It is driven by a community, and it's driven by use cases that you bring to the community, right? So we're not saying you're more important than the next person, but just bring us the use cases. Let's talk about it. Let's chat, and let's come to a resolution.